This time I will design a doubly reinforced beam from your book. It is problem 5.35. The problem says that there is a beam. The factored moment in this beam is 950 cubic feet, and the owner or the architect, they recommended that the beam size will be 14 inch and this size will be 28 inch plus some cover. So we cannot exceed this size. The materials we are using has 4 KSI concrete and 60 KSI steel. Now we have to design this beam. Design this beam means what is the amount of reinforcement. Before solving this problem, let me clarify one thing, that the problem will not tell you it is a singly reinforced beam or doubly reinforced beam. I mean, whether the reinforcement will be only here or we need reinforcement here and there. The problem will not tell you. You will have to find it. So any other information in this book? No. So now we will start solving this problem. Now I did not delete my steps of doubly reinforcement design from my previous video because I will follow this. So what are the steps for designing doubly reinforced beam? Step number 1, calculate load. We do not need to calculate. Why? Because the step number 2, calculate factored moment. The moment is already given in the problem. Because these 2 steps take some time. In this problem, our main concentration is whether you can design a doubly reinforced beam. So we sometimes give you the moment directly so that you do not need to waste time there. Our main concentration is here. So step number 1 is we do not need it. Step number 2 is done. That is 950 cubic feet. So what I will do here, I will directly write here step number 1 and 2. I got my moment 950 times say 12 cubic inch. Okay. Now I have to think about is a singly reinforced beam or doubly reinforced beam. Why I don't need to think about? Because my size is given. Whenever I know my size, whenever I know that I cannot exceed that size, there is a chance that it will be a doubly reinforced beam. So I will have to check it. How to check it? Calculate mu over phi BD square and find rho. Find rho from where? In your appendix there are tables, table A8 to A13. So depending on the book, but in our book it is table A8 to A13, we will find rho. Okay, so let us calculate this portion first. What is mu? Mu is 950 times 12. It is in cubic inch, but in your table they use it in pound inch unit. So I have to multiply by 1000 also, because this value in your book is in pound inch in this unit. Divide by 0.9, and then B is 14, D is 28 square. What is this value? This value is 950 times 12 times 1000 divided by 0.9 divided by 14 divided by 28 square. I got 1154. So 1154. If I go to your book, appendix for this material, 4 KSI, 60 KSI, in table A13, 60 KSI, 4 KSI, I can see the maximum value. The maximum value given is 912, and that is for rho 0.018. That means it is exceeding. So this value is exceeding the limit. That means my rho is more than the rho max. So this is our condition. Why do I know condition? Because this book lists the value of rho up to the rho max. So as my value is more than the max, that means my rho is actually more than my rho max. So my beam is doubly reinforced beam. Okay, so my beam is doubly reinforced beam. So this is not my condition. So this is my condition, doubly reinforced beam. If doubly reinforced beam, select rho equals rho max. So what is my rho max? I can select from A7 or I can select from A13, both. So my rho max is 0.0181. Yes, 0.0181. So I got my rho. I have selected the maximum possible, or the maximum for which my tensile strain. Again, what is rho max means? Rho max means my tensile strain will be 0.005. That is the value we consider rho max. Okay, this is done. Calculate the moment carried by this. Now we have to calculate the moment carried by this rho max. How to? For this, find this value from table. So we already found this value from table. What is that value? This value. So 912. Then the moment capacity will be 912 times rho BD square. Okay, 912.914 D square. How much moment it can carry? If I take my calculator, 912.91428 square. Now this value is in pound inch. So I will divide this value and say 12 and then 1000. So divided by 12,000, I got 750 cube feet. A cube feet, the reason is my initial moment was in cube feet, or even I can multiply 12. That is not a problem. Okay, so if I provide maximum reinforcement, this beam can take 750. My moment is 950. What to do? What is my balance or excess moment? 950 minus 750 equals 200 cube feet. 200 cube feet moment is my excess. Now I need to provide additional reinforcement to carry this moment. Okay, so this is my equation. So 200, the Fy is 60, D is 28. Okay, now you can see this is 60 KSI. So this value will be in cube, but inch. So I will multiply by 12. So this is cube inch. My moment is cube inch. This is KSI. So my units are consistent. So D is given 28. Now what is D prime? D prime is the where you will place your combination reinforcement. If you place here, what is this distance? That is D prime. So you will select this. Typically, whatever you select here, whatever the space you leave here, typically 2.5 inch for interior beam, that will cover your clear cover, stirrup, everything. So I will also use here 2.5. Now this D prime, you will select it. So 2.5 inch. So what is the reinforcement? So if I do the calculation, 212 I did not use P here. There should be a P here. Okay, I forgot this. There should be a P here. So 200 times 12 divided by 0.9 divided by 60 divided by 28 minus 2.5. I got 1.74 inch square. Okay, so I got 1.774 inch square. Okay, so this is my reinforcement, my additional reinforcement I will use here. Now my turn is to find my reinforcement there, AS prime. How to find it? These are the steps. Okay, so what is my AS1? AS1 is my maximum reinforcement that I provided somewhere here. Rho equals rho max. So AS1 will be, I did not calculate here. My AS1 will be, if I write here, AS1 is rho max BD. So rho max is 0.0181. My B is 14. D is 28. So 0.0181 times 14 times 28. So 7.1 inch square. 7.1 inch square. Okay, so then I will use here, okay, I'm doing 7.1 inch square, 60 divided by 0.85. A prime C is 4, B is 14. So this is KSI, this is KSI, it will cancel each other, inch square, inch, so it's consistent. Okay, if I solve it now, I got 8.9 inch, 8.94 inch. What is beta 1? Beta 1 is 0.85. We know for A prime C, for KSI, beta 1 is 0.85. Excuse me. Then what is C? C is A over beta 1. A is 8.94 divided by 8.5. So divided by 8.5, I got 10.5. So this is 10.5 inch. Then strain in compression steel. C is 10.5 minus D dash is 2.5, as we assume 2.5 here. Okay, let me write the value. So C will be 10.5, D prime will be 2.5, C will be 10.5. Then what is my tensile strength? 10.5 minus 2.5 divided by 10.5 times 0.003. I got 0.00228. Okay, then what is my yield strength? Yield strength is FY 60,000 divided by the modulus of steel. Modulus of steel is 29,000 KSI. We know that. So we will find this. How to find this? So this is 60 and this is 29,000 KSI. What is this value? So 60. Now again, where I got it, it is the material properties. 60 divided by 29,000 KSI. I got 0.00207. So my strain in compression steel is 0.00228 and here 0.00207. That means this value is bigger. That means this is our case. S prime greater than Fy. Then AS yields. That means our AS is yielding. That means our Fs prime. Fs prime means the stress here in compression steel is Fy. So I do not need this category then. So I do not need this category then. Okay. Then what is my reinforcement here? Using this equation. Now, as Fs prime is Fy, I can write here now Fy. Delete it, I can write here Fy. Fy cancel. As prime is As2. What is As2? 1.74. 1.74 inch square. So we solve this problem. How? We got our reinforcement in tension zone, in compression zone. So if I draw somewhere, say here, so if this is my beam, my reinforcement here is 1.74 inch square. My reinforcement here will be AS1 is how much? AS1 somewhere here 7.1 plus AS, or write it down, AS1 plus AS2. Here my reinforcement is AS prime 1.74. So 7.1 plus 1.74. So 8.84 inch square. So I need to provide 1.74 inch square here, 8.84 inch square here. Now then you can select your bar, place it. Okay, let us go a little more. How many bars you will choose? But that takes time. Detailing takes time. So I don't know whether I should do it or not. Do it very quickly. So 8.84, I can see here 7 number 10 bar. 7 number 10 bar is 8.86. Or even 4 number 14. 4 number 14 is 9. Okay, 7 number 10. 7 number 10. So 1, maybe 2 here, 1, 2, then 3 bar here. 7 number 10. And then 1.774. 1.74. 1.74, that means I can provide 3 number 7. So 3 number 7 here, 7 number 10. Okay, then I can the tie bar should go here. The tie bar, as it is number 10, my tie bar can be number 3. You know that if your main reinforcement is up to number 10, tie can be at least number 3. If your main bar is more than number 10, it should be now at least number 4. Okay, so more or less it is good. I will delete this, then show the dimension. This portion should be 2.5 inch and the center to this should be, now you can see, oh, my two bars should be side by side. Then I do not need to provide extra material here. So 2.5 inch. Now I should set the minimum spacing here. Minimum spacing should be 1 inch or bar diameter. Bar diameter here is set 2 bar. That means 2 number 10. So what is the diameter of the number 10? Diameter of the number 10 is 1.27. So 1 inch or 2, 1.27. That means 2.54. That means my space here should be at least 2.54. I should check it. Do I have it? Let us check. So what I will do, here to here, I will deduct 2.5 inch. Here to there, I will deduct 2.5 inch. So this 2.5 inch is from the outer bar. Okay, then what is my space available here? 1 bar, 2 bar, half here, half here. So 3 bar. So 3, 1.27. What is my diameter here? Combined diameter. We should determine the combined diameter. Combined area divided, the combined area of this is pi d square by 4 equals my combined area. What is the area of 3 bar? area of 3 by 1.27 also, yes. So 3 times 1.27, 2.2 inch. So D is 2.2 inch. So the combined die is 2.2 inch. Okay, again to the calculation, total is 14 inch. Make more room so that it is clear to you. So 14 minus 2, 2.5, minus 3, 1.27, minus combined diameter 2.2 divided by 2 is, I got this clear space 1.495 inch. I need at least 2.54. So it did not meet my criteria. Then what I will do? Now, if you leave it, it's not mistake. We need this clear space so that my aggregate goes inside. So what I will do, you can leave as it is. You can say fairly okay. If you say fairly okay, it is okay actually. Because we need this, but we have this. Now, it is not mathematics that it should mathematically satisfy. No, not like this. If you do slightly less, it will be difficult for labor to compact the concrete mix. If you want to solve this problem, how can you solve this problem? This 2 bar, instead of placing like this, you can place up and down. You can place up and down. One reinforcement on top of this. In that case, what you need to do? You may need to add some reinforcement, some material here. Because the problem did not tell us that what is the total height. Maybe you can add quarter inch or half inch material here. Now this is an option. It is not that you must do it. Or even you can do something else. You can select. Okay, let me solve this first. If you do up, that is another option. Up, then add some reinforcement material here. Make it 3 inch. 3 inch. Make it 3 inch. Then total will be 31 inch. 28 plus 3. That is another option. So one option is whatever we did first, good. Other option is, okay, place it up down and add half an inch more. Or even 1 inch more. You can make it 3.5. You can make it 31.5. That should be okay because the problem did not clarify one thing. Other option can be, you can simply, okay, if you do not like this option, what I will do, 1, 2, 3, number 7 bar. Here what I will provide? I need to provide total, if you can remember, 8.84 inch square. 4 number 14. If I provide here 4, 1, 2, 3, 4. 4 number 14 bar. Then I think I will have sufficient space. Okay, check one more time. If I provide 14 bar, what is the dia for 14 bar? Dia 14 is 14 bar is 1.693 inch. Okay, then what is my clear space here? I have 14 minus 2, 2.5. I am deducting 2.5 here, 2.5 there. Then 1, 2, half, 3 bar, 3 of this divided by 1, 2, 3 space. So this will be my clear space. So 14 minus 2, 2.5 minus 3 times 1.693. Is it 1.693? Yes. Divided by 3. I got 1.3 inch clear space. How much do I need? At least the bar diameter. Is still not good. Is still not good. But again, this is also an option, although it is mathematically not correct, but you can. Or yeah, number 14 bar, I think you cannot bundle it because it is so big. And maybe I will conclude here because it takes very cool brain and lot of times. I should not do this detailing in video because it has no end of improvement. You can improve a lot, but what I will say is that in this problem, my dimension is so small and the moment is so huge. It is typically not common. So this is why this problem is happening, and we could not satisfy the minimum clear space criteria. But again, as long as you can pour concrete inside the reinforcement, it should be good. So I will conclude this example here. Again, to summarize, I gave you the steps, follow the steps, and then you can solve the problem. Finally, detailing takes time and passion. So that is not our part, but I tried to give you some insight what to do. Just go to the book, find some bar, place it, check the minimum reinforcement, and do several trials, then you will get a optimum solution. The minimum space of 1 inch or bar diameter, it is not always, it is the code recommendation, but if it is slightly less, then it should be okay. So in my next video, I will solve another problem.